Hemant is also here in our class. He will be attending our class as revision only. We will be covering our syllabus. Okay. So, yes. Till now we have started gravitational force. We have started with Newton's laws of gravitation. Newton's laws of gravitation you must have studied in class 9th as well.
That phone is in
What does it say? It simply says two things. That force between two masses is directly proportional to their product of their magnitude. Force is proportional to Ma and Mb. Ma and Mb are the masses of particles or two balls situated at some distance. And it is also inversely proportional to the inverse of square of distance. Inverse of square of distance is 1 upon r square, r being the distance between these two points A and B. So when we remove the proportionality sign, we get Gm1 m2 upon r square. Then G is called universal gravitational constant. The value of G is 6.67 into 10 to the power minus 11 Newton meter square per kilogram square. Okay. And it is what? It is equal to the value of force, equal to the magnitude of force which will exist between two particles when the distance between them is 1 meter and their masses is also 1 meter. Then the force of attraction between them will be capital G, numerically, okay? Next, vector form of gravitation. That also we have seen in class 9. If you ever prepared for Olympiad, then this gravitational force vector form is also taught in class 9. Class 10 for competitive exam. After that, we saw its important features. And these features you also see. It is always attractive. It is independent of medium between the particles, means whatever medium we are keeping in between, whether it is vacuum or it is water or some oil. The force between two particles will be independent of that. Third, it is a long range force. Long range means it will act on long distances as well, like sun and earth, as well as moon and earth. Getting it, all 7 planets, 8 planets. All the things are bound with the force of gravitation. Next, it is independent of the presence of third body. Like force between sun and earth is independent of force between moon and earth. Means moon and earth can have their separate gravitational force. Jupiter and earth can have their separate gravitational force. But the force between sun and earth is independent of all of them. Getting it? It is independent of all of them. Next, it follows the principle of superposition. Now, what does the principle of superposition say? It says that net force will be given by F1 vector, F2 vector, and so on. Means vector sum of all the forces acting on a particular particle. Getting it? Anshul, getting it? Next, it is the weakest of the forces present in the nature. Bulk forces, weakest of the bulk forces present in nature. Means like on Earth, this gravitational force is very, very weak. That's why we are unable to feel a force of attraction between the two mountains or two human beings. Two human beings or two cars or two trucks, two trains, they are not getting attracted towards each other because air resistance is much more powerful than this force of gravitation. Next, it's a conservative. What do we mean by conservative force? By conservative force, we mean that work done will not be dependent upon path. It will be dependent only upon the position, initial position and final position of the body. Work done is dependent on that.
పిలో వీడియో కూడా 6 months ఎంత ఉండేవి.
Okay.
పిలో వీడియోస్ ఉన్నాయి కదా,
మరి పాతవన్నీ పోయినాయా?
వినేసిన
అన్ని రికార్డ్ కావద్దు మరి
రికార్డ్ ఎందుకు
పక్కన ఒకసారి విన్నాక అన్ని పేరు విన్నాయా?
అన్నీ రాసేసా కూడా.
డౌట్ వస్తే
డౌట్లు కూడా సపరేట్ పేపర్ రాసి పెట్టేసా. ఇంకా ఒక్క మంచి ఉంటే అయిపోయాను. పోయినా కదా రికార్డ్ చేసినట్టు అవి కూడా
రికార్డ్ చేసుకోవడం మేలు కదన్నా. చెప్తే ఆ పని చేసింటే బాధ్యతగా. సినిమాలు అంటావు. ఏం చేయాలి సినిమాలు చూసి నేను?
ఏం చేస్తామండి, ఎవరితో ఇవ్వాలి అంతే కదా. ఏం పని ఉంది?
నేను కానీ నీకు విషయం ఏమైనా వినాల్సి వస్తే ఒకసారి నేను వినుకుంటాను.
అవసరం లేదు నాకు. నోట్స్ ఉన్నాయి వాళ్ళు రాసినవి. రోజుకు అదే కానీ 10 hours అయింది.
Now write down a question. This example, mass M is broken into parts, M1 and M2. How are M1 and M2 related so that force of gravitational attraction V2 is maximum? Try solving it. Anshu, समझ में आया question? Two masses are broken such that gravitational force between them is maximum. Question is of maxima and minima. Maxima and minima. How to calculate maxima and minima? ध्यान है अंशु? डबल डिफरेंशिएशन करते थे, याद है? In basic mathematics we studied that first of all we will differentiate the equation, equate it with 0, differentiate it again. Greater than 0 is for minima and less than 0 hai, then that will be maximum. Getting it, Hemant? Do you remember it? any answer? Anshul? Hemant, any answer?
कर रहा हूँ सर, एक सेकंड। Sir, we got F1 equals to M2.
What did you get?
Sir, F1 equals to M2.
M1 equal to M2. How?
So first of all, I've written the equation of forces if you M1
Fine.
and differentiate it.
Fine. अंशुल समझ में आया? देखो
नहीं सर,
हमारे पास में हमें क्या दिया हुआ था सबसे पहले? We were given with a capital M mass. From this M mass हमने two pieces कर लिए. These two pieces were taken out of this mass M1 and M2. It means automatically if we are taking M1 from M, then this M2 is what? M minus M1. Right. M. 1 and 2. Because capital M. Okay. Therefore, the force will be G M1 M2 means small m multiplied by capital M upon R square. R is the distance between them. Okay. This is the equation of force which we are getting. G M into small m minus small m square upon R square. This equation we are getting. This is equal to force vector. Differentiate it with respect to mass means dF upon dm. What do we get? G upon R square is constant. So G upon R square is on one side. Capital M is constant. So capital M will remain as it is. M will be differentiated and it will become 2 into small. This we are getting after differentiation. So for F to be maximum, first condition is differentiation of F must be equal to it means M minus 2 will equal to 0 or small m into capital M by 2. When small m is capital M by 2, M1 is capital M by 2, then M2 is also capital M by 2. So M1 equal to M2 is equal to capital M by 2. Got it? Take it down now. आगे बढ़े भी अंशु आया सर till this point. Next question. If the diameter of Earth becomes twice its present value, but its mass remains unchanged. But its mass remains unchanged. Then how would be the weight of an object on the surface of Earth affected? Option A, weight will become 1/4 of its value. B, weight will become 1/3 of its value. C, weight will become half of its value. And D option, weight will remain same. Try solving it. Read the question twice. Try to understand what the question is asking and then try to solve it. Okay, now any answer? Hemant?
Sir, 1 second. Sir, 2 seconds.
Sir, 1/4 of its volume.
1/4 of its value. Shabash, very good. This is the correct answer. कैसे आया? Let us see that now. See one thing. Weight is what? Weight is mg. And this is nothing but force, which is equal to g m1 m2 upon r square. Now when the diameter or radius of Earth becomes double, and mass remains unchanged, means mass of Earth is constant, but diameter means radius is getting double. Radius is getting double. Then what will be the new weight? New weight will be g. Mass of Earth is constant. Mass of body is still constant. Radius of Earth is now twice the previous square of it. So that will become what? G m e m upon 4r square. This is clearly the previous force. Answer is W by 4. Got it? This was easy question. Taken down?
Has.
Next is acceleration due to gravity. See, we know one thing. What do we know? That force due to gravity is mass into g. G is what? Acceleration due to gravity. And from Newton's law of gravitation, we know one more thing, that g m1 m2 upon r square. If this r is radius of Earth and mass is mass of Earth, then this is the force acting between Earth and the body. This part is constant, and value of this part is equal to capital G. Getting it? From here we can write a small g is equal to gm upon the square of radius. Gm upon square of radius. Now how it will vary on Earth? capital G is clearly dependent on radius of Earth or wherever we are present. If we are present far away from Earth, then this will be different, and if we are present on the poles, then this will be different, because distance from the center to the poles is lesser than that of equator. Okay, so write down, consider the Earth to be a homogeneous sphere. Homogeneous sphere means what? Contents inside the Earth are considered to be same everything. We are not considering that at some points it is having diamonds, and at some point it is having deposits of gold and other metals. At some point it is having just gases in form of water. At some points it is also having water, but all these things are found only in Earth's crust. And the crust of Earth is very, very thin part. Thin in the sense like an apple. The skin of an apple as compared to the full size of the apple. The pulp of the apple, if it is considered to be mantle, and the seed part is if it is considered to be core, then the skin part will be considered as crust of Earth. So Earth's crust is very, very, very thin part. Over that thin part only, oceans and all the other bodies are contained. Whenever these parts are cracked, wherever these are cracked or very thin crust is there, at all those points we see volcanic eruption. So we are not considering that, we are considering Earth to be a homogeneous sphere of radius r and density rho. First case, at a point above Earth's surface. Okay. Now let us imagine that this is our Earth and this is our point P. On this point P, we need to find out the force of gravitation. This point P is at a distance r. Therefore, what will be the gravitation force? Gravitation force is a central force, so we will take it from the center. Here, the gravitational outside the Earth if the entire mass of Earth is at its center. Okay. So what will be the gravitational force at this point? Gravitational force at point P will be equal to G, capital M, mass of Earth, small m, mass of the body, divided by r square, distance of point from the center of Earth. Okay. Getting it? And here, value of small g will be equal to G into capital M upon small r square. This will be less than 9.8 meter per second. Okay. Because we are very much above the surface of Earth. ये करना
सर तो मतलब जी की वैल्यू पोल्स पे डिफरेंट होगी।
आंसर हाँ poles पे different. Value of G will be different at poles and will be different at equators. Why? Because shape of Earth is said to be an oblate spheroid. It is not a sphere. It is oblate spheroid. Like
सर तो इक्वेटर पे ज्यादा होती है या पोल्स पे?
poles पे ज्यादा. कहाँ से ज्यादा?
सर पोल्स तो ऊपर हुए काफी हाइट पे होते हैं.
पास है. That is which is closer to the center. No. भाई ये गोला है. गोले की हाइट
आवाज कट रही है.
there is no height of it. We hello. हाँ अभी आ रही.
हाँ सर.
देखो because we always draw map like this, we keep north in upward direction. That's why we feel that north side is upward. Actually north is not upward. Nowhere it is upward. We are on a sphere. हम sphere पे हैं भाई. इंडिया यहाँ पे कुछ India is like this here. This is Saudi and this is African continent. Okay, so India is like this here. Thing is, here we feel that north is in upward direction, but thing is, each and every point is nearly at same distance from the earth, except this point on the equator is at the farthest distance and this point is at the closest distance. अर्थ जो होती है ना, तो टमाटर देखा थोड़ा, टमाटो or anything like that, orange is there. Orange is never perfect sphere. It is somewhat compressed at the axis. Similarly, earth is also compressed at the axis. It is not perfect sphere. It is called oblate spheroid. Shape of earth is called to be oblate spheroid. Okay, like an orange. So this is radius at equator and this is radius at poles. So radius of earth at poles is less than radius of earth at equator. Always remember that. Okay. That's why force due to gravity is greater at poles. Than at centers. Taken down. लिखा है यहाँ पे
डायनेमिक इक्वेटर होना चाहिए.
Oh sorry. Okay, dynamic equator. Done. Okay. So at point above Earth's surface we have seen. Now at points below the Earth's surface, how to calculate a small g at points below the Earth's surface? See now, if this and we cave, then what will happen? Then the mass which is present beneath our feet will be this sphere. This smaller sphere is present now beneath our feet. Okay. So the part which is going to attract us will be this. And the radius of full Earth is still r. Okay. This is our point P. Here we need to calculate gravitational force. Let us assume that we dug inside Earth up to t distance. Let the mass which is kept at P be smaller. Now, write off. Consider a point mass small m at point P at a depth small d from the surface. This point P lies just outside the sphere of radius r and inside the shell of thickness r minus small, d equal to r minus small. Okay. Now, the force due to this outside shell will be cancelled out. Why? Because whatever mass is present on this side, same mass is present on this side also. Okay. So it is all inside, captured inside a uniform shell. Each and every part of the shell is going to attract it, and hence the force of attraction will become zero ultimately. Okay. Therefore, the only part which will be attracting this will be the part which is beneath this point P, that is this sphere of small r radius. What will be the force due to this small r? Therefore, force due to sphere of radius small r F equals to G small m into mass of sphere of small r radius upon r square. Now density of Earth is rho. Since rho is what? Density of Earth. Therefore, mass of this sphere of radius small r, this will be equal to density into volume. Density is rho and volume is 4 by 3 pi r cube. Okay, this we are getting 4 by 3 pi r cube. Getting? We can write it as what? Rho into 4 by 3 pi capital R cube into small r cube upon capital R. Both of these will cancel out. Ultimately, this part will be remaining. So what is this now? This is density of full sphere. Density of full sphere multiplied by volume of full sphere will be equal to mass of full sphere. Mass of full sphere into small r cube upon capital R cube. This will be the mass of sphere of small r radius. Okay. Now put it M R now. Capital M R cube upon capital R. M2 is small m upon R square. That is small r square. Now this is small r square and small r cube will cancel out. One r will be remaining. So we are getting G capital M small m upon capital R cube into small r. This will be the force. Therefore, small g equals to divided by m. Small g equals G m upon capital R cube into small r. Everything is constant. This small r is remaining. Or inside the earth, small g is proportional to small r. Very important. Take it down. हाँ अर्षद, समझ में आया यहाँ तक?
Straight लिखा सर थोड़ा ऊपर करते हैं।
रोल सर
लिख लिया
done. Okay then. That's all for today. From here we shall continue from our next class. Okay. समझ में आया अंशुल?
हाँ सर
इसको प्लीज रिवाइज करते रहना. ओके. हेमंत, did you get?